Today we'll be reviewing what we've learned so far in Unit 4. So the first day of the unit, we talked about coordinate plane and relations. We're going to use this table here to fill in the rest of this chart. So our ordered pairs are going to be 1, -5, our first ordered pair, and then 0, 7, next ordered pair, -2, 3, and 1, 1. Remember, for the domain, we need to list our smallest x value first. So I'm pulling the values from here. The smallest one, it looks like, is -2, and then 0, and then 1. Even though 1 repeats whenever we do not write it twice in our domain. Our range are our y values. So I'm going to start with the lowest y value, -5, and then go up 1, 3, and 7. For the inverse, I'm simply taking my ordered pairs and swapping my x and my y values. So instead of 1, -5, I'm putting -5, 1. Instead of 0, 7, I'm putting 7, 0. Instead of -2, 3, I'm putting 3, -2. And then 1, 1 actually is the exact same as the inverse. Is this a function? No, it is not a function because, check out this, I have an x value that repeats with different y values, so no, it is not a function. Let's go ahead and graph our points. So 1, -5, I'm going to go to the right 1 and then down 5 for the point. Let's call this A, B, C, and D. So this is point A. Point B is 0, 7, so I'm not going to go left or right at all, I'm just going to go up 7. That's going to be point B. C is -2, 3. And then D, 1, 1. So right 1, 1. For the mapping, remember to label your x and your y, your input, output, domain, range. And we're going to put our x values in order, -2, 0, 1. No repeats. Put your y values in order, -5, 1, 3, 7. Now, we are going to map my x values to the y values they correspond with. So -2, 3 was an ordered pair, so I'm going to map -2 to 3. 0, 7 was an ordered pair, so I'm going to map 0 to 7. And then 1 maps to -5 and 1. So notice if you look at your mapping, I can tell it's not a function because there's 2 arrows coming from the same x value. So that indicates to me that it is not a function. Next, we talked about functions in domain and range. So remember, we've got our vertical line test. If you can run a vertical line through the graph, then it passes the vertical line test, then it's a function. So check out number 1. If I put a vertical line anywhere through this graph, I'm touching 2 points at once. So it fails the vertical line test. It is not a function. You can only touch 1 point at a time. Let's try it with our second graph. Running my vertical line through the graph, I'm only touching 1 point at a time, so that is a function. Now, for tables or ordered pairs, you're just looking simply at the x values. And no repeats allowed. So notice that 12 repeats, so that's no good, that is not a function. And then for number 4, I don't have any repeating x values. They're all different. And so it is a function. Notice my y's repeat, but it does not matter. My y's can repeat, it's the x's that cannot. Next, we've talked about domain and range. So remember, domain are my x values, range are my y values. So this is a tricky one. We can use set and interval notation because it's a solid graph. I can't just list separate points. I'd be here literally forever. So for the domain, I'm going to start with my lowest x value. So go ahead and figure out what the lowest point on your graph is. This happens at -4. I've got solid points there, so it's going to get a bracket. Remember, we talked about in inequalities unit, solid point gets a bracket, open point gets a parenthesis. Okay? And then I'm going to go to the farthest right point. So sandwiching farthest left, farthest right, my x values are between -4 and 0. 0 also gets a bracket because it is included as a solid line there. Now for set notation, we always start with x such that. In this case, x is between two values. X is between -4 and 0. It's greater than or equal to -4, but less than or equal to 0. Now for the range, I'm going to look for the lowest y value first. So that's going to happen right here. That's the lowest point on my graph. So that looks like it happens at -2. Again, it's a solid point, so it's going to get a bracket. And then the highest point on my graph is +2. Also gets a bracket because it's included. So let's kind of follow how we did the set notation for our domain and kind of mirror what we did. So we start with a brace, then y such that. Now this time y is between -2 and 2. So put y in the middle. Y is greater than or equal to -2, but less than or equal to 2. So there you go. There's your set and interval notation. Make sure you've got that down. You can pause it if you need to, because I'm about to erase so that we can do the next one. Alright, so let's go back to our domain here. We would like to know what the lowest x value is. Well, if you try and put your pencil on the farthest left point of the graph, which is here, it's an arrow. So that means that it actually keeps going to the left forever and ever and ever. Well, that means it's going down to -infinity. And if you try to go to the rightmost point of the graph, it's an arrow. It keeps going forever and ever and ever to +infinity. In fact, anytime you have a U shape like this with arrows on the end, this is going to be exactly the same. And the set notation will be exactly the same. X such that, if you remember for all real numbers, it's always x is all real numbers. So it's written like this. Again, that's going to be the same for every U shape that goes on forever. Even if it's upside down U, the domain is going to be exactly the same. So that's super important. Alright, let's do the range. So I'm going to go to the lowest point of my graph, where it turns around, and that's 0. Solid line, so it's going to be a bracket.
Good afternoon.
And put your pencil on the highest point on your graph. Well, those are also arrows. They're shooting up forever and ever and ever, so they're going to infinity. They're never going to stop. So my set notation always begins with y such that for the range. And this time, there's only one boundary, 0. So would you say y is always greater than 0 or less than 0? Definitely greater, because it goes above 0. And it's going to be or equal to because I'm including 0 as a possible value. This is a point, so I do have a y value of 0. I know that's tough stuff, so feel free to pause, go back, and really try and work through this, because this is your review before you take your test in a couple class periods. Alright, go ahead and flip over. Let's look at function notation. Remember, function notation is just another way to write your function rules. So for number 1, it says if f of x equals x plus 5, find f of 2. So remember, this is an input, so I'm going to take x and replace it with 2. So f of 2 is going to be 7. And you can write that as an ordered pair as well, 2, 7. B, it wants me to do a similar thing, but this time x is -1. So I'm going to replace x with -1, and I'll get 4. So f of -1 equals 4, or an ordered pair of -1 and 4. Now, be careful. Do not go, oh, great, 12. Go ahead and plug that in. No. Why can I not input 12? Well, you said it. It's not an input. It's an output. So I have to set my function, x plus 5, equal to the output of 12. And let's unravel the equation by using opposite operations to figure out what the input must have been. So in this case, it will be an input of 7, and the ordered pair would be 7, 12. So there you go. Be careful watching for what's an input, what's an output. Now for number 3, we're going to use, oops, I wrote over something. Yeah, okay. So given the domain of -1, 4, and 6, what is the range, aka what's the y value? So we're going to plug in each of these x values. -1, so put parentheses around -1, of course. So when I plug that in, I'm going to get 2 times -1 squared, which is +1. 2 times 1 is 2, and 2 plus 3 is 5. So there's our first range value. Next, we're going to plug in 4. So f of 4 is going to be 2 times 4 squared plus 3. 4 squared is 16. 2 times 16 is 32. 32 plus 3 is 35. And the final one, hopefully you're leaving yourself enough room, is to find when x is 6. So we're plugging 6 for x. So 6 squared is 36. 36 times 2 is 72. 72 plus 3 would be 75. So my range is going to be 5, 35, and 75. Let's go ahead and write that in our correct range notation, somewhere where we've got room. 5, 35, and 75. So there you go. Pause it if you need to, because I'm about to erase all of this. Alright, so now we're going to look at the graph and evaluate our function. So it says, find f of 0. So remember that wants us to go to where we have an x value of 0. What's our y value there? Well, it would be 0. So f of 0 equals 0, or the order here, 0, 0. For f of 1.5, we are going to go where we have an x value of 1.5, 1.5, and kind of follow that down. So for an x value of 1.5, it looks like I've got a y value of -11. So there you go, 1.5, 11. And then C, be careful, it wants to find x when y equals 0. So y equals 0 in 3 places. Right here, and right here. So it happens at -3, 0, 0, 0, and 3, 0. So it wants to know all of my x values where that y value is 0. So I'm going to say, well, it happens when x is -3, when x is 0, and when x is +3. For slope, we're going to go ahead and sketch an example of positive, negative, 0, and undefined slope. So positive slope goes up as you look left to right. Remember the little man test. Little man's looking up. Negative slope goes down as you look left to right. Your little man's looking down. 0 slope is a flat line. And I always say you can make a Z with it if you're doing it correctly. And then undefined is a vertical line, and you can make a U with it if you do it correctly. So those are just some fun ways to remember that. Next, we're going to find slope from 3 different starting points. So first, we're going to find slope from a line. Remember that we use the equation for slope rise over run when we're looking at a line. So pick 2 points where you cross through an intersection. So I'm going to use this point and this point. And count your rise. I went up 3, and then I went left 2. So that gives me a -3 over 2 slope. And it should be a negative slope because little man's looking down. It's a negative line. Now slope from 2 points, we have to use a totally different equation. We have to think of it as y2 minus y1 over x2 minus x1. So label your points x1, y1. I'm sorry, I wrote 2. x1, y1, x2, y2. plug in, we're going to have 4 minus 2 over 3 minus negative 1. But I don't leave it minus negative 1. Let's make that a plus. So 4 minus 2 is 2. 3 plus 1 is 4. And always simplify. 2 over 4 is a slope of 1/2. And then last, to find slope from an equation, we use yet another equation. Y equals mx plus b, where m is the slope. So we've got to solve this equation for y. Start by moving your x term to the other side. So subtract 3x on both sides. Drop down your negative 3y equals, put your x term first, always. And then divide everything by the coefficients. And simplify. Negative 3 over negative 3 cancels. Again, negative 3 over negative 3 cancels to give you 1x. And negative 9 over negative 3 is positive. So I've got a slope of positive 1. So there you go. There are no you-dos for this, so you're just going to go ahead and get started right away on your classwork and homework. You may use your notes and go back in the video if you need to, but really work through some of this stuff, especially what you find to be the most difficult, maybe domain and range. Thanks for listening.